Hey, Seventh here from Lambda Edge, where we look at finance and technology. If you're new here, make sure that you click the subscribe button, and everything that we mention in this video, including the Git repository, will be available in the description box below. In this 5-part series, we are going to build a Recon system step by step, and in the part 2, we are dealing with OpenCSV. The objective, as mentioned, is to process a CSV file using OpenCSV library. We'll also be looking at alternatives to OpenCSV and to see what benefits that OpenCSV provides. In order to find the difference, we'll be using two different files. One is the holding file, another one is the custody file. I'll be showing how these two files look like, and for the first one, we'll be using OpenCSV, and for the second one, we'll be using a Streams API. First, looking at the custody CSV file, it just has 5 rows, and it's supposed to have the custodian view of things, and each row is uniquely identified by the security ID, which is what we will use as a primary key in matching with the accounting side of things, which is the holding CSV. And it also has a fund, and we are going to look at just for one single fund. As you can see, I have marked a special character to identify the header record. Because I'm not using OpenCSV, the processing of the header should be different from processing of the rest of the rows. I also have a model class for custody, which just simply represents the list of columns, as well as a constructor and some getters and setters. In this case, I just have one getter and setter. If you have to do this, you'll have to do for every single column over here. And I also have a toString method just to print out nicely on the console. We'll be first processing the custody CSV file. I'll be using the Java NIO file API to read the file, and the files class has a lines method on it. The lines returns every single line of the file name passed as a stream, so that I can actually use the Java 8 stream functionality. Before going any further, we'll need a brief introduction of what streams is, and definitely this needs a separate section in itself, but for this purpose we would do a very high level overview. Java 8 brought the important aspect of functional programming into its feature. Java util.stream is specifically meant to have the functional programming element into it. A stream represents a sequence of elements that can be either from a collection, a list, or in our case, a lines of file that we're reading from the CSV. Then it also has intermediate operation and a terminal operation. The stream operations, which are intermediate, can return a stream, so we can chain multiple intermediate operations without using semicolons. The terminal operations are either void or returns a non-stream result. Back again in IntelliJ, we'll be using the Streams API to perform some intermediate and terminal operations on the lines that we are reading from the custody CSV. So the first operation that we'll be performing is to filter out the header. As you can see in the custody CSV, the first line, which is a header, is represented using the hash, and I'll be filtering out the hash. The next one that I'll be performing is to map every single line that I'm reading into the POJO object that I've created for custody. So the way to do that, using the flat map method, and the flat map takes in a lambda function which will translate every single line that I'm reading into a custody object. And what this function, as you can see briefly, it just splits the line using the comma separator and then assigns each of these column into separate elements, and the final return value is mapped into the custody object, and I'm using the stream.off method to return each of these as a stream so that I can further process them. So the final ternary operation that I'll be using on this would be a for each method to simply print. And let's just save this and build and run this to see what the output that we're getting. As you can see, the 4 lines that are in the file processed and printed out. The next file that we'll be processing is the holding CSV file, and it's more or less same as the custody view of things, except that it doesn't have the broker and few other things that's needed for the custodian perspective. And the key difference from our processing is the first line. As you can see, the header doesn't have any special character. In the case of custody, we had the hash, but in the case of holding, we don't need to have that, because we are going to use a library called OpenCSV, and it is smart enough to find out what the header rows are, and we don't have to programmatically do that anymore. And looking at the holding model class, what I have used here is the Lambok library. It is important to understand why we're going to use this, because if you look at the custody Java, we had all the getters and setters, and also the constructor method that we'll have to create it manually, including the toString method. But that's not needed. That's not needed because you have the Lambok library providing all of that using some simple annotations like the .add data and add getter, etc. What is Lambok and why should we use it? Let's just go back to the Lambok site and to see what's the value they really offer. As written in this summary, never write a getter or equals method again. And with one annotation in your class, you can actually have the full feature of a builder, automate your logging variable, and much more. That's what the Lambok project is for, and we'll be using this just to demonstrate how easy and simple it is for our file mapping perspective. Here we are in the pom.xml file, and this shows the dependency for Lambok, and the version that we'll be using in this project is 1.18.12. The next thing that I want to show in this particular file is the usage of the OpenCSV function CSV bind by name. What this function does is it simply maps every single column into the class variable. As you can see, security ID is mapped for the column security ID, so on and so forth. Now, before going any further, let's explore a few of the methods which is provided by OpenCSV. Here we are in the documentation page for OpenCSV, and we'll be interested to see two key methods. The first one is the CSV Reader, and the second one is a CSV to bean builder. The first method, CSV Reader, simply reads the file and stores that into a reader object, which you can then process line by line into an array of strings. But the key method that we'll be interested in will be the CSV to bean builder, which will translate the columns into the bean object that we have, and this way we can then further process using a stream or similar nature. We are in the project and we are looking at the pom.xml file where we add the dependency, and for OpenCSV the version that I'm using is 5.2. This is the way we add the OpenCSV dependency into the project. Back again in IntelliJ, we have another try with resource method. This time we'll be using the files buffer reader. This is just to show the different ways in which you can read a file. I'll be using the standard character set of UTF-8 to process this file. And the first method that I'll be using in OpenCSV is the header column mapping strategy. And this tells the OpenCSV that the class that I'll be using to map will be holding class, which is our Java object, and the next one that I have to use is to map each of these columns into a bean. And there are two chaining methods here. One is the strategy that we have already defined here, and second one is just to simply ignore leading white spaces. If we do a build on this, it is going to populate every single row into the bean that we have, and further from there on we can then simply parse it into the holding as a list of holdings, and you can then use the streams API to further process. In this case, I'm just having a simple filter operation by a specific security, and I'm going to print that out in the console. This is just to show that OpenCSV is much more simpler to use rather than writing all these line to position mapping that we had to do, and individual column mapping, individual header mapping that we have to do. All that is coming packaged with the CSV library that we are using. Let's build it and run it to see what we have as an output for processing both the CSV files. As you can see, the first 4 rows are from the custody file. We're printing every single line there, but the second one is the holding object, or the second CSV file that we have, which prints just the matching record of security ID 302. We've seen 2 most important library for reading and processing a CSV file, which is the OpenCSV and also the usage of Lambert. We will build from here on the whole Recon system, and in the next series we will see how to actually find the mapping and the differences between the 2 CSV files. Thanks for watching. Hope this is useful for you.